Okay, so we're going to be solving systems by elimination, day number 2. So, first things first, content objective is students will be able to solve systems of equations by elimination, of course. Language objective is students will be able to explain how to eliminate a term to solve for a variable. Why am I learning this? Well, it's important for real-life problems like how many of each shirt or pants you can purchase with a specified budget. So, first, let's go over some background knowledge, quickly reminding ourselves. So far, we've learned a total of 3 methods to solving a system. First was by graphing, then we went on to using some algebraic approaches to it. And in this case, with the graphing method, we went ahead and graphed our 2 equations, figured out where the solution was based on where the lines intersected. This could sometimes be time consuming, especially if it wasn't already in slope-intercept form. But the most important thing was it wasn't always accurate, especially if it wasn't nice integers. So this had its limitations. So then we went ahead and used the substitution method to solve. But then yesterday we went ahead and learned the elimination method. So let's go ahead and quickly review what the elimination method looks like. In an example like this, you're trying to find a variable to eliminate. Sometimes it will automatically eliminate on its own. In other cases, you're going to have to manipulate one or more equation to get that to happen. Here, I'm noticing that it's probably going to be the easiest thing to go ahead and just eliminate the x's because they're both already negative 8x's. Now it's just a matter of making one of them negative and the other one positive. Now, one thing that you have to be very careful about when you're using the elimination method is you want to make sure both equations are in standard form. Or at least make sure that the x's line up, the y's line up, the equals line up, etc. So in this case, again, I want to eliminate the x's. I just need to make one of them negative so that it actually eliminates. One thing that I keep in mind is I want to try to keep my other variable positive, so that can kind of help me determine which equation I should make negative, which one I should make positive. So in this case, it's going to be a better idea to make this equation negative to keep my y's positive. So I'm going to go ahead and multiply the entire equation by a -1. Here, this one's going to stay the same, so I'm just going to go ahead and rewrite it back as -8x plus 9y equals 8. This one's going to change to a positive 8x, a positive 7y, and a -8. At this point, I can successfully eliminate the x's, leaving me with 16y equals 0. Now simply divide both sides by 16, and I'm left with y equals 0. But of course, I'm not done yet. I need to go ahead and plug this into one of the original equations so I can figure out what the other variable is. So in that case, I'm just going to go ahead and use the first one. It really doesn't matter. I'm going to go ahead and do -8x plus 9y equals 8. I'm going to go ahead and take the y and substitute it in for y. I had a lot of students get the correct variable, but then when they plugged it in, they plugged it into the wrong variable. So here, since it says y equals, I'm plugging it in for y. So I have -8x plus 9 times 0 equals 8. So I have -8x plus 0 equals 8. So here, this is basically gone. Divide both sides by -8. And I'm left with x equals -1. So at this point, since I have an x and I have a y, I can go ahead and say that I think the solution is -1, 0. And of course, we always say that I think because we want to make sure the answer is correct by first checking it. So let's go ahead and check the answer. Here, a quick reminder that the x's are -1s and the y's are 0s. So here, I'm just going to go ahead and rewrite the equation. Then I can go ahead and substitute it in. -8 times -1 plus 9 times 0 equals 8. Here we have 8 plus 0 equals 8. This is true, so it works for the first one. But we can't stop there. We want to make sure it also works for the second one as well. Negative 8x minus 7y equals 8. So here we have negative 8 times negative 1 minus 7 times 0 equals 8. Here we have 8 minus 0 equals 8. This totally works out. So I can go ahead and say that the solution to this system, we want to make sure we know what a system is indeed negative 1 comma 0. In the instructions here, it says, what could you multiply one of the equations by to eliminate a variable? Set up the problem. So here they're not really asking us to actually solve, they just want us to set things up. So here what you're going to want to do is get the coefficients to match up, with the exception that one has to be negative and the other one has to be positive. So how do you do that? Well, you kind of tie in something called the lowest common multiple. We used to work with these a lot, especially when we're trying to find a lowest common denominator. So here, let's take a look at the x's. You have a 4 and you have a negative 9. It's always nice if one of the coefficients is negative and the other one's positive, because that's what you're going to need. Okay, so here between a 4 and a 9, the lowest common multiple is going to be a 36. So you're going to have to change the first one by a negative 9. And you would have to change the second one by a positive 4. So you are going to have to change both equations. So this is a last resort type of thing. So let's take a look at the y's. For the lowest common multiples for the y's, well, let's take a look at the coefficients. We have a negative 3, and then here it's technically a negative 1. So here the lowest common multiple is a 3, but since they're both negatives, one's going to have to change to make it a positive. 3 is not going to have to change, but the negative 1 will have to by 3. But again, since they're the same signs, I'm going to have to multiply a negative 3. So in this case, you'd only have to change one of the equations, but for eliminating the x's, you're going to have to change both. So in this case, I'm going to go ahead and say that I'm going to change the second equation by multiplying it by a negative 3. So let me show you that it works. The first one's going to stay the same, 4x minus 3y equals negative 16. And the second one, we're going to have to distribute, so 27x plus 3y equals, let's see, positive 26 times 3, 78. So here the y's definitely cancel out. So in order to answer the question, I'm going to say I am going to change the second equation by multiplying it by a negative 3. Okay, I'm going to do one more example with you, and then I'll give you a chance to try numbers 4 and 5 on your own. So here, what I like to do is kind of break it down to what are my options for eliminating the x's, what are my options for eliminating the y's, and seeing what my better choice is. So here, let's take a look at the x's first. The coefficients are negative 9 and a positive 5. Again, what's nice is one's a negative, one's positive. That's definitely helpful. Here, the lowest common multiple is a 45. So that means this first one's going to have to change by a 4. And the second one's going to change, oops, not by a 4. Rewind. It's going to have to change by a 5. And the second one's going to have to change by a 9. Okay, so now let's take a look at our options for the y's. For the y's, our coefficients are 10 and negative 5. The lowest common multiple is 10. What's nice already is one's positive, one's negative. So that's great. I'm not going to change the signs at all. The first one's going to stay the same, but the second one you are going to have to multiply it by 2. So taking a look at our options, should we change both or just one? I'm going to say, let's just change one. So in this case, I am going to have to change the second equation by multiplying it by a 2. And again, let me show you that it does work out. The first one's going to remain the same, negative 9x plus 10y equals 28. Here, this is going to change to 10x minus 10y equals negative 30. So here the y's definitely cancel each other out. So in order to answer the question, I would say I'm going to change the second equation by multiplying it by a 2. So now what I'd like you to do is go ahead and try numbers 4 and 5 on your own. Okay, so let's see how well we did. First, let's take a look at the x's. What are my choices? The coefficients is -2 and -8. Here, the signs are the same, so I'm definitely going to have to multiply one of them by a negative to change one of them to a positive sign. Here, the lowest common multiple is an 8, so the first one's going to have to change by a 4, and the second one's not going to have to change. Here, like I said, since both signs are the same, one of them is going to have to be negative, so this has to be multiplied by a -4 in order for the x's to eliminate. But again, let's double check with the other option. Here, let's check out the y's. For the y's, we have a 4 and a -10. The lowest common multiple is a 20. So here, again, since one's positive, one's negative, I'm not going to have to worry about multiplying by a negative number. But here, you're going to have to change this by multiplying it by 5 to make it a 20, and this one's going to have to be multiplied by 2. So you have your options. Do you want to change just one, or do you want to change both? And if I were you, I will always want to try to only change one. If I'm forced to change two, that's another story. But always try to change one if it's an option. So at this point, I'm going to go ahead and say that I'm just going to change the first equation by multiplying it by a -4. But again, let me prove it to you. Here, this is going to change to positive 8x minus 16 equals 16y equals a positive 56. And here, this one's going to stay the same. So we have -8x minus 10y equals -4. Here, I can show you that the x's definitely cancel each other out. Okay, so now let's go ahead and check the last one and see how well you did. Between the lowest common multiple for the x's, we're looking at a coefficient of 8 and -1. So what's nice is one's positive, one's negative. The lowest common multiple here is an 8, so the first one's going to stay the same, but the second one's going to have to change by an 8. What about the y's? The lowest common multiple is between a -1 and a 6 here. What's nice again is one's negative, one's positive, so we're not going to have to deal with multiplying an equation by a negative number. The lowest common multiple is a 6, so the first one's going to have to change by a 6, but the second one's not going to have to change. So here, you have some options. You're only going to have to change one of the equations for eliminating the x's, and only one equation for eliminating the y's. But now it's a matter of, would you rather multiply everything by 8, or would you rather multiply everything by 6? So just keep that in mind. You also might want to keep in mind the numbers that you're going to be multiplying by. So if maybe one of the numbers are larger, you might want to refrain from that option and choose an equation that has smaller numbers. So there's so many different factors to look at, but whichever one you choose, you are going to still get the same answer. So just remember that. So here I am going to go with this just because I think multiplying by 6 seems smaller. So here I'm going to multiply this first equation by a 6, leaving me with 48x minus 6y equals a -27 times 6. 12 plus 4 is 16, so 162. This one's going to stay exactly the way that it is, so -x plus 6y equals 21. So here's the proof. The y's definitely canceled each other out. Okay, so that's going to conclude this portion of the lesson. Okay, so now we're going to go down to actually solving them, not just setting them up, but actually solving the solution for the actual system. So in this case, I'm going to take a look here. I have the choice of eliminating the x's and I noticed the lowest common multiple for the x's is going to be 6, so this one would get to stay the same and this one would have to change by 3. Or I could eliminate the y's. So here I can go ahead and recognize that the lowest common multiple is going to be 4. So this one would stay the same, but the second one is going to have to change by a 4. So to keep things small, I'm going to go ahead and eliminate the x's. So I'm going to multiply this entire thing by a 3. So real quick, we just got to double check. If I multiply this by 3, will it actually cancel out my 6x? The answer is yes, because this one's a positive and this one would be a negative, so that's perfect. I'm going to go ahead and keep this the same. So we have 6x plus 4y equals 22. This one's going to change, leaving me with a negative 6x plus 3y, whoops, a little further, equals 6. So at this point, I've successfully canceled out the x's, leaving me with 7y equals 28. Simply divide both sides by 7, and I'm left with y equals 4. However, I'm not done yet. I need to plug it back in to figure out what x is. I'm going to go ahead and use the second equation, so we're going to use negative 2x plus y equals 2. I'm going to go ahead and take this value of 4 and substitute it in for y, because it says y equals. So now I'm left with negative 2x plus 4 equals 2. Now you're just going to get rid of the constant, leaving us with negative 2x equals negative 2. Divide off that coefficient. The negatives cancel out, leaving me with x equals 1. So here at this point, I can go ahead and say that I think the solution is 1 comma 4. And you know that I always say think because we need to still make sure that we check our solutions. So let's go ahead and do that real quick. Here we're going to go write down the equation first. 6x plus 4y equals 22. Quick reminder, the x's are 1s, the y's are 4s. So 6 times 1 plus 4 times 4 equals 22. Here we have 6 plus 16 equals 22. 22 does indeed equal 22, so it works. Now we're going to have to check the second equation. Negative 2x plus y equals 2. Here we have negative 2 times 1 plus 4 equals 2. Negative 2 plus 4 equals 2. I am left with negative, whoops, not negative 2. It's going to be positive because there's more positives. So 2 does indeed equal 2. So it does check out. So again, I want to say that the solution to this system, and again, it's called a system. It's more than one equation. To the solution to the system is indeed 1 comma 4. Okay, so now what I'd like you to do is go ahead and pause the video and try number 7 on your own. Okay, so let's try this out. So here for number 7, let's do a quick breakdown of the lowest common multiples. For the x's, we have a 10 and a 5. And then for the y's, we have a 3 and a 9. The lowest common multiple here is a 10. The lowest common multiple here is a 9. So for the first one, I am going to have to change the second one by multiplying it by a 2. And for the y's, I'm going to go ahead and change the first one by multiplying it by 3. So I would prefer to, here, to be quite honest, multiplying by 2, multiplying by 3 is not going to make that much a difference. So what I would check on now is making sure on, am I going to have to multiply by a negative or am I going to have to multiply by a positive? So here, since they're both negatives for the x's, I would have to multiply by negative 2. For the y, since one is negative, one is positive, I am going to have to just multiply by 3. So just looking at my options, I do think it's easier to go ahead and change the, eliminate the y's by changing the first equation by multiplying it by 3. So that's exactly what I'm going to do. So I'm going to go ahead and change this first equation by multiplying it by a positive 3. That is going to change my equation to a negative 30x minus 9y equals, here I'm going to do some side work, 26 times 3, 18 carry the 1, 78. And then here, this one's going to stay exactly the way that it is, so negative 5x plus 9y equals negative 8. So something that you want to be very careful about is make sure that your variables actually eliminate, because if they don't, that means you're probably multiplying by the wrong coefficient. So here the y's cancel each other out, leaving me with negative 35x equals 70. Simply divide both sides by negative 35, and that leaves me with x equals negative 2. However, of course, we're not done. We're going to have to substitute that in. I'm going to go ahead and plug it into the second equation here. So you have negative 5x plus 9y equals negative 8. Now, at this point, you're going to go ahead and take the value for x, substitute it in, and you're going to be left with negative 5 times negative 2 plus 9y equals negative 8. Here we have 10 plus 9y equals negative 8. Subtract 10 from both sides. You have 9y equals negative 18. Divide both sides by 9, and we're going to end up with y equals a negative 2. So at this point, I can go ahead and say that I think the solution is negative 2 comma negative 2, but we say that we think because we still need to check our answers. So let's go ahead and check the answer real quick. Here, I'm going to first write down the equation. I'm going to go ahead and now plug it in. The x's are negative 2's, but so are the y's. So here, after I plug it in, I must simplify everything. This is 20. This is a positive 6. This does work for the first equation, but I still need to check the second equation. Again, first write it down. And then you can go ahead and substitute in the values that you got. And then you're going to simplify. So here it's 10, here it's a minus 18 equals negative 8. Negative 8 does equal negative 8. So it does check out. So I'm going to say the solution to this system is indeed negative 2 comma negative 2. Okay, so now I'm going to go ahead and show another example. Then I'll let you go ahead and try some more to practice. So for this one, I'm going to go ahead and assess what I think is going to be easier. For the x's, I can recognize that the lowest common multiple is going to be a 10. So I would have to change this one by multiplying it by a negative 2. Why a negative 2? Because the signs are exactly the same. So I'm going to have to change 1. Here, the lowest common multiple is a 6. So I'm going to have to change the first one by a 3. And it would have to be a negative 3 because they're both positive. So I think my first option is going to be easier. I should change the first one by multiplying it by a. First you think hopefully 2, but then you recognize, oh look, my signs are the same, so I have to make one of them negative. So let's go ahead and change this equation. It's going to transform to 10x minus 2y equals a negative 20. Now this second one is going to stay exactly the same. So I'm going to have negative 10x plus 6y equals 20. Here the x's cancel out, leaving me with 2y equals 0. Simply divide both sides by 2, and y equals 0. Now before I move on, I do want to mention this. Some of you may have thought it'd be easier to multiply the second equation by a negative 3. Would you still get the same answer? Absolutely. So please don't feel like there's only one method. There's several ways. Some might be easier than others, but yet again, you're still going to get the same answer, and that's all that matters. Okay, so back to our work here. I need to go ahead and plug this value into one of the originals to figure out what x is. So I'm going to go ahead and use the first one. I'm going to go ahead and take this y and make sure it goes in for y and not any other variable. So negative 5x plus 2 times y, which is a 0, equals 10. So here we have negative 5x. This is going to be 0, so I'm not going to write it down, equals 10. Divide both sides by negative 5. And I'm left with x equals negative 2. So at this point, I'm going to go ahead and say that I think the solution is negative 2, comma 0. It's always think because we still need to check our work. So let's go ahead and check our work here. The x's are negative 2s, the y's are 0s. First, you got to write down the equation. Then you can go ahead and start plugging in the values. The x's are negative 2s and the y's are 0s. So here you have a 10 plus 0 equals 10. This is true. It works for the first one. Second one, you got to write down the equation first. Then you can go ahead and start plugging in the values. And then you must simplify and check to see if it works. It does. So yet again, I can confidently say that the solution to this system is indeed negative 2, comma 0. Okay, so now for the very last one, I would like you to go ahead and pause the video and try this one on your own. Okay, so let's see how well we did. So here you have some options. You can eliminate the x's. You are going to have to change this one by multiplying it by 10. For the next option to eliminate the y's, you are going to have to change one by multiplying it by a 2. So what do you think is easier? Hopefully you went with a smaller number, but is it really difficult to multiply a number by 10? Not exactly. So it's totally subjective. You do what's easiest for you. I'm going to go ahead and show the multiplication of changing the first equation, because that's what my mind would automatically do. And the other reason why I would do this is because here, in order to eliminate the x's, I am going to have to multiply by a negative number since they're both negatives. But for the y's, one's negative, one's positive, which is really nice. So I'm going to go ahead and change this first one by a positive 2, which is going to lead to a negative 2x plus 20y equals a negative 48. Now this the second equation is going to remain the same, so it's going to be negative 10x minus 20y equals 0. Here the y's do successfully cancel each other out, leaving me with a negative 12x equals a negative 48. Simply divide both sides by a negative 12. The negatives cancels here, leaving me with x equals 4. But of course, we're not done. I need to substitute that into one of the originals. I'm going to go ahead and substitute into the first one. So negative x plus 10y equals negative 24. Go ahead and substitute in this x in for the x. So I have negative times 4 plus 10y equals negative 24. Simply add 4 to both sides, and you're left with 10y equals negative 20. Divide both sides by 10, and y equals negative 2. So at this point, I can go ahead and say that I think the solution is 4 comma negative 2. And again, we always say think because we still need to check our work. So let's go ahead and check out our answer. Quick reminder, x's are 4s, y's are negative 2s. First, you're going to write down the equation, and then you can go ahead and substitute the values in. Then once you substitute the values in, you just need to simplify. Oops, minus 20 equals negative 24. This works out, so now I need to just check the very last one. Again, you're just going to write the equation first, and then you can go ahead and substitute the values in. Now that you've done that, you're going to simplify. Negative 40 plus 40 equals 0. This is true. So I can confidently say that the solution to this system is indeed 4 comma negative 2. So guess what? That is going to conclude our lesson for today. Thank you so much for tuning in. And as always, until next time, bye.